Hello friends, this video on chemical bonding part 24 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched part 1 to part 23. Let's take sp3 hybridization now. So in sp3, we have one s orbital and 3 p orbitals. They hybridize and they form 4 sp3 orbitals of equivalent energy and shape. Right? Example, if you see, this is my 1s orbital, 1p, 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 right? All these merge and they hybridize to form, this is my sp3 hybrid orbitals. You see there are 4 sp3 hybrid orbitals, right? And all are having equal energies, correct? And these have 25% s character and 75% p character because there is only one s and 3p involved, right? And it is tetrahedral shape with 109.5 degree as the angle, correct? So this is all about sp3 hybridization. Let's take some examples on that. And also note that carbon with single bond goes for sp3 hybridization. So let's take some example for this. So let's take carbon example of methane CH4. So carbon, if you see, the electronic configuration will be 1s2, 2s2, 2p2, correct? This is the electronic configuration of carbon. So I'll create this box for the valence electrons, valence shell, because that's what I'm bothered about. So 2s2, 2p2, correct? This is the electronic configuration for carbon. And if you see the carbon looks like this only. So if you see 2s2 is 2 electrons in the s orbitals and 2 p orbitals have 1 electron each. That's the look of carbon atom. Now what will happen? One electron will move from 1s to p and it will go to sp3 hybridization. You see, once again I'll show you. It is all 2s, 2p, 2p, 2p. One electron moved from here to here and it all became sp3 hybridized. So you see now I got 4 sp3 hybridized orbitals. Let's see in demo. So I have 4 hydrogen molecule coming towards this carbon and it became like this. Now if you see, I got 4 sp3 hybridized orbital. That means all are 4 all sp3. And if you see, all of this p orbitals are involved, so I don't see extra p orbital here. All the p orbitals are involved, and I got 4 sp3 hybrid orbitals, all with equal energy and 1 electron each, right? And this hydrogen also came with 1 electron. Since this orbital, sp3 hybrid orbital of carbon and this s orbital of hydrogen both had 1 electron, so they overlap. Let me make the hydrogen electrons red. Right? So these overlap. Here also if you see, this is s orbital of hydrogen overlap with sp3 hybrid orbitals of carbon because both had single electron, and that's what the theory says, overlap theory. If they have unpaired electrons in the orbitals, they overlap. Here also if you see, s orbital of hydrogen and sp3 hybridized orbital of carbon overlap because they have 1 electron each. Here also they overlap, and that's why if you see, the structure of CH4 is tetrahedron. Experimentally also they have found this. And please note, carbon also forms sp2 hybridized in case of ethane and sp in ethine. So carbon forms sp3 also, sp2 also, and sp. We'll take both these examples now. Just I want to explain the same shape using the Vesper theory also. If you draw a structure of or Levi structure of CH4, you'll find that carbon is not having any lone pair. So it is a case of 0 lone pair plus 4 bond pair. So Vesper theory says that if I have a molecule with 0 lone pair and 4 bond pair, it has to be tetrahedral. That's what the shape of CH4 is, right? So using Vesper theory also we can get the same shape because the Vesper theory says that if I have a molecule with the central atom having 0 lone pair and 4 bond pair, That means it will give a tetrahedron shape, and that's what shape of CH4 is. Let's take some more examples of sp3 hybridization. So nitrogen is has atomic number 7. So electronic configuration is 1s2, 2s2, 2p3. We'll consider the outermost valence shell. So we'll have 2s and 2p3 in this fashion. This is my 2s will have 2 electrons and 2p will have 3 electrons each. Let's draw the shape of nitrogen. So this is the outermost I am drawing. So this is my nitrogen. 2s, 2 electrons, and there are 3 p orbitals, each has 1 electrons. Correct? Now what will happen is, it will just go sp3 hybridization. If you see here, there is no transfer of electron. It just went sp3 hybridization. That's all. Let's see how it comes. It is like this. So in this case, if you see, the first sp3 hybrid orbital is filled with 2 electrons. The second sp3 hybrid, let me write sp3 in all this case. This is sp3. So this is sp3, so we got 4 sp3 hybrid orbitals. Right? The first sp3 is filled with 2 electrons, so it won't go for any overlapping or no bond formation, no pairing. This sp3 orbital has 1 electron, this has 1, all these 3 has 1 electron each, see, 1, 1, 1. And this guy, the dark green, has 2 electrons. Now the hydrogen atoms will form a bond with this, because hydrogen atoms also have s orbitals with unpaired electrons, right? So they'll form the bond. Correct? Hydrogen electrons are green in color, you can see that. They'll form a bond. That's what you see the shape also of NS3. It is like this. I have this is sigma bond, sigma bond, sigma bond, and I have one lone pair. And this shape is exactly what I can get from Vesper theory. Correct? You see the Vesper theory also, it predicts the same shape because it has one lone pair. Here if you see the lone pair, and I have my bond pairs here. Let's take one more example of sp3 hybridization. Let's take water. So water, in a water I have oxygen will go for hybridization. So oxygen has atomic number of 8, that means 1s2, 2s2, 2p4. We will be bothered only about this part, 2s2 and 2p4. So let's draw this. So I have 2 molecules in 2 atoms in 2 electrons in s orbital and 4 in p orbitals. Correct? Now what will happen is, let's draw the structure also of water. So I have outermost, this is 2s orbital, right? It has 2 electrons. Then this is my p orbital in the blue color has 2 electrons, and my 2 more p orbitals in green color I have made because they have 1 electron each, right? See, these are all p orbitals, this and this, but just it had 2 electrons, the other had 1 electron, so I have put different colors so that you can understand this. This is 2s, 2 electrons, 2p in blue, 2 electrons, 2p in green, 1 electron, 2p in green, 1 electron. This is how a oxygen molecule looks like. It will go for sp3 hybridization without any transfer. You see, this was the case, and instantly it will go for sp3 hybridization. Correct? You see, just like that it will go for sp3 hybridization. Now if we see, the way it works is, it will go for hybridization like this. In this case, if you see, this I got 4 sp3 hybrid orbitals, but out of that my 2 sp3 hybrid orbitals have 2 electrons each. If you see here, 2 electrons each, and the other sp3 hybridals have 1 electron each. So these guys won't go for pairing. Only these 2 orbitals, these are all my sp3, this is sp3, this is sp3, this is sp3. All are sp3 hybrid orbitals, but 2 are filled with 2 electrons. It won't go for any overlapping. These 2 will go for overlapping. And that's how the structure of water is. If you see, there are 2 orbitals like this, and by Vesper also it is the same structure, right? sp3, sp3, these are my bond pairs, and these are my 2 lone pairs. My lone pairs are like this, and my bond pair are Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.